All right, guys, this is still lesson 5.1. This is the second day of it, and this will go a little bit quicker, I think. We just have one more set of identities to get through, and then do a few of the practice problems, which will use everything. So if you're looking at this first page, you're thinking, we did this already, and you're right. And look at the second page, you're right about that one too. Well, let's just talk through them anyway. So talk about the trig identities. Why do you want to learn these trig identities? Because if you get a complicated function, it's nice to write it as a much simpler function, usually in terms of just sines and cosines. So things that you need to know off the top of your head, so things you want to have memorized, and maybe you have them already. You definitely want to have memorized reciprocals. Sine, reciprocal is cosecant. Cosine, reciprocal is secant. Tangent, reciprocal is cotangent. You want to know those off the top of your head. The quotient identities, and again, all these we did yesterday, so it should look familiar. The tangent is sine over cosine, or the cotangent is cosine over sine. Those you want to have memorized. So these are called the fundamental identities. So these are ones that any good trig student would know just off the top of their head. And then the third set, which you did not have to have memorized in the first chapter, now you do need to have these memorized, are the Pythagorean identities. And so these as well, you will know off the top of your head. Wouldn't that be a good quiz to give you? And just see if you had all these memorized? Not a bad idea. All right. Here's the new set of identities today, and it's the negative identities, and they're down here. If you're looking at all this stuff, it's like, wait, where are the identities? Here they are, but I want to explain how they work, and I think the easiest way to explain how they work is to think about their graphs for a minute. And so the question becomes, if I'm taking a sine or a cosine or a tangent, so say like the sine of 20 degrees, and I take the cosine of 20 degrees, and the cosine of negative 20 degrees, the question is, how do those compare to each other? And one idea would be, try that in your calculator. Take the cosine of 20, take the cosine of negative 20, and see what you get. Another way, though, to think of it, because we just spent chapter 4 on graphing, is think about a cosine graph. And say you came over here, pi fourths, or 20 degrees, or whatever you want to do, and you're getting the y value. Say you go to the left, so a negative pi fourths, and you get the y value. Do you see that this graph is symmetric to the y-axis? Does it make sense if you take the cosine of pi fourths or the cosine of negative pi fourths? You're getting the same y value either way. And that symmetry continues everywhere. Come to the right, come to the left. Look, the graph is the same on both sides. So we get this identity. The cosine of negative theta is the same thing as the cosine of theta, meaning if you put a negative inside a cosine, it doesn't matter. So the cosine of 20 degrees, try it in your calculator. It's the same as the cosine of negative 20 degrees. And I guess I remember with this graph, when I look at the y-axis, if I go right, if I go left, look at that. That graph is the same. Look at the sine graph. That is definitely not true. When I go to the right, look, the sine graph goes up. When I go to the left, the sine graph goes down. And it continues that way. Look, it goes up, then it starts going down. This goes down, it starts going up. It does everything the opposite. So if you tried in your calculator the sine of 20 degrees, and you tried the sine of negative 20 degrees, you would get the exact opposite of each other. And again, I always think of the graphs when I try to remember these facts. So how do we write that? We say the sine of the negative angle is the opposite of the sine of the angle. And again, you could put both negatives on one side. The negative sine of negative theta is the sine of theta. So the negative out here in front means they're opposites. So it needs to go on one of the two to show, look, they're opposites of each other. If I put a negative angle and a positive angle, they are truly opposite of each other. So we have one function, cosine, where it doesn't matter if it's positive or negative. One function, sine, where they're opposite each other. And the tangent is always our tiebreaker. And in this case, the tangent is just like the sine. Look, as I come away from the origin, we go right, it goes up, left, it goes down. So tangent is like sine. The tangent of theta is the opposite. Ooh, there's a typo there, isn't there? That should be the tangent of negative theta. And I've already printed these out for you guys, so you'll have to fix that on your own sheet. I'll check tomorrow and see if you fix that. So the tangent of negative theta is the opposite, or the negative tangent of theta. And again, nothing to stop you from putting the opposite on this side as well. So just know, when you put in a negative to a tangent, it matters. It makes it the opposite. You put a negative into a sine, it matters. It makes it the opposite. You put a negative into a cosine, doesn't matter. It's the same thing as if you took the positive of it. If you look on page 188 in your text, you will see a summary of all 4 sets of identities we just had. And again, these are your fundamental identities. These are the ones you want to have off the top of your head. Okay, let's do just a little bit of practice here. And this practice isn't just the 4th set, this is everything going on here. And basically this will look a lot like your homework. It may have been plagiarized from your homework. And it's matching. And we have the left side we want to match with the right side. And everything is at play here. And how do you even know where to start? Well, I guess when I do any of these identities, I start with the complicated things and try to make them simpler. We're used to doing that in math, taking something complicated, make it simpler. If you start with something simple, it's kind of hard to know how you make that complicated. So I don't think I'd start with 1. I think I'd start with something complicated. So let's take a look here. I don't know, what looks complicated? This looks complicated. Sine squared plus cosine squared. Immediately that should strike you. Say, wait, that's one of my identities. That's a Pythagorean identity. I know what that equals. That equals 1. So I know now 5 goes with A. So I'm just going to keep that out here. So 5 goes with A. We've got that one done. Okay, what else is complicated? I don't know. Sine over cosine is a little complicated. And sine over cosine, that's a quotient. I have a quotient identity. And don't you know your quotient identity? Sine over cosine is tangent. Well, look at that. That matches up. So 2 and D go together. We'll circle that one. We're done with that one. Kind of maybe cross them off here, too. Okay, what else looks complicated? Oh, let's look on the left side. Cosine over sine looks a little complicated. Isn't that the cotangent? Look at that. I have B over here. So 1 goes with B. We're down to a couple more. Oh, look at this with a negative inside the cosine. We just did that one. A negative inside a cosine, guys, it doesn't matter. It's the same thing as the cosine. So 3 goes with E. And I know we're done, but let's just do it anyway. Tangent squared plus 1, that's one of our Pythagorean identities. That really is a secant squared. And look at that. That was our last choice. That was C. So when you approach problems like this, with the matching or something like that, I think I'd look at the complicated trig functions and I'd try to make them simpler. And that pretty much was the point of our whole first section here. Do you know these identities? Can you use those to take something complicated and make them simpler? And guys, that completes the lesson.